All right, hello, my wonderful students. This is part 2 of foldable number 2. And for this one, we're going to be graphing. So we're going to be graphing a logarithmic function. Tongue twister. And we have this here. We have our y is equal to the log 3 of x, and we have to kind of graph that here. So we come to a little dilemma, and I'll show you why. Because we know this here already. By doing our work, we know this is going to be equal to 3, or x is going to equal to our base of 3 to the y power. But the problem is that we don't know how to graph this. This is something that we haven't really worked on, but we do know how to graph this. If we were to take the inverse of this, this ends up looking like, which is y is equal to, I'll do equal to 3 to the x. And we have done this. So we're going from here, after coming from here to go to here, and then we're taking the inverse. And once we find the inverse, we can kind of like switch the table around and then graph our function of logarithmics. Okay? So this is the way we are going to work it out. So we're going to create our table first. So let's go and do that. We have this one here. And then we're going to go and do -2, -1, 0, 1, 2. This is going to be our x. This is going to be our f of x, which in this case is our 3 to the x power. And this is going to be our y. Okay, so we can go ahead and get started with this one. So we have this one would be 3 to the -2, which ends up equaling, I should have gave a little bit more space here, but this is going to be 1 over 9. Because if we were to do this, it would be 1 over 3 squared, which is equal to 9. Then we'll just go and do 3 as well, because we did make our graph huge. We made it in a bigger scale so we can go a little further. Then we have 3 to the -1, which is equal to 1 over 3. So that's our 1/9 here, 1 over 3. We have our 3 to the 0 power, which is equal to our 1. 3 to the first power, which is 3. 3 squared, which we know is already 9. And 3 to the third power is 27. So we can graph our inverse. So we'll do our inverse in, let's do it in blue for this one here. I don't know why I'm feeling blue, but I'm really feeling blue right now. So our first one's at -2. Oh, we should do it. I didn't put a -3 here for x. So our -2 is going to be at 1/9. So -2 is about there. It's going to be at 1/9, which is really close here. Oops. I just realized this is negative. 1/9 is here. So we got to ignore that blue dot. So we're going to just cross it out with our red. So I guess we're not going to use red anymore. So it's going to be on there. Sorry, Mr. Brown, forgot that positive is above the line. So, and then at -1, which is about right here, is going to be at 1/3, which is just a little bit higher. At 0, we're going to be at, let's see, at 1, which is a little bit higher than that. Then at 2, we're going to be at 3. Sorry, at 1, we're going to be at 3, which is here. 2, we're going to be at 9, which is about right there. And at 3, we're going to be all the way at 27, which is here. So this is going to be all the way up. Oop, little hiccup there in the graph. And there's 2 ways to do this, okay? We know that whenever you have an inverse, it's actually a reflection over, oh man, I guess I'll show you this. I've been using this as a ruler because I didn't have a ruler. Some mail that came in for McDonald's. But if you fold it in half, it makes a nice ruler. Promotional. Alright, so it makes a reflection over this here to the other side. So that needs to show that when we do our graph. So we have, this is our table for our function of this one here. So in order to get the function, the inverse, we're just going to kind of flip each variable. So our inverse, which is going to be our y is equal to log 3 of x, is going to be equal to our x y of, so negative 2, negative 1, 0, 1, 2, 3. And over here we're going to have 1/9, 1/3, 1, 3, 9, and 27. So now we're going to do this one in red. So this one we have our x is 1/9, which is really, really close. It's going to be at negative 2, which is about right here. Then we have our 1/3, and at negative 1, which is about right there. And then we have our 1/0. So 1/0 is about right there. We have our 3/1. So 3/1, which is about right here. And then we have our 9 and 2. And then our 27. Oh, I didn't go that far. 27 would be like here. And then this would be at 3. So if we were to graph this here, we would go like this all the way to there. And as you can see, they are inverses of each other because they are the same distance here as it is to here. And same thing here to here, here to here, and they're reflexive over the properties. So this is one of the cool tricks that we learned using prior stuff, using the inverses to find our graph, and then knowing that it's a reflection over the x equals y graph here, which is our dotted line, to show this. So this is just connecting prior knowledge to what we've done relatively close in the past.